Tech Talk. So many times in this industry, there's solutions that are developed because of a frustration or because someone has found a better way or thought there's got to be a better way to do this, and they dive in and create something. And that's kind of the story of what happened with our talk today behind this drone-based inspection technology. John Kiesel from Division 7 Roofing and Carrick Willis have developed this solution and are partnering with John Kenny from Cotney Attorneys and Consultants. And I asked them to talk about how this came about this partnership, about what this means for the industry. So welcome, guys. I will turn it over to you.
Thank you. Yeah, thank you for the introduction. You know, as Karen said, we had a lot of issues over the years with takeoff accuracy, and we do a lot of re-roofing, and that takeoff piece is a very important part. And 80% of the time, 90% of the time, you know, roofs get put on and there's not issues, but when there were or are, you can tie that back to that point in time when the takeoff of the roof that we were estimating, if that process had a flaw in it. And no matter what we tried, checklist forms, whatever, human error just entered into the equation. With Carrick's expertise in drones and roofing experience, we feel like we have an excellent solution that starts with roofing takeoffs and progresses through the whole entire operational enhancement of doing things. So one thing led to another. So we really feel like we've got a great in-house performable operation that many others can duplicate.
And add on to that, you know, I've had some history myself with issues of, you know, being on a roof, being a foreman, getting a job packet, trying, you know, while I'm still working on a job and I don't have time to get out to that job, I'm trying to get all the details of this job from a little packet, and you just can't see what's going on. You can't figure out what's going on, and it's hard to get a plan together. And that's where it became personal for me of, okay, I want something so I can have a real plan, because I'm a data heavy person, and that's what I like. I like information, I like data, but it has to be compiled and organized in a way that's useful. And photogrammetry is what allows us to do this. And for those of you that don't know, photogrammetry has actually been around for a very long time. It originally started back in the early 1900s, you know, even goes back to 1850, all the way back to the early 1400s with Leonardo da Vinci in perspective viewing. But most people here today have probably had some sort of interaction with photogrammetry in the sense of using Google Earth, using some sort of mapping software. You're looking at what's called an orthomosaic. And an orthomosaic is just simply a picture that's been corrected for the curvature of the Earth, essentially. So that way it's geo-rectified in its accurate measurements. And photogrammetry in and of itself, I just like to have the simple definition of you can take pictures, take measurements from them, or create models from them. And in the past, this was much more difficult, and you needed, you know, you started with space, and that's where it's, you know, well, before satellites, but it started with, you know, pigeon carriers that they tried to do, and then balloons, and then they moved into airplanes. But most common that you're seeing is Google Earth and space. It's where most people have probably had some sort of interaction with photogrammetry. So it's not brand new, it's adapting new age methods or using newer technology like drones, and they have GPS built in that enables us to take this next step in the photogrammetry space. Like I was saying, you have aerial applications. So, I mean, EagleView and some of your other ones that's been around for a while, it's the same theory. It's the same type of use case. They just used to have really high-end metric cameras. Now, new methods and formulas make it so that's not necessary. You can use a DSLR, you can use a cell phone camera, whatever it is. If it can take pictures and you've got enough overlap, we can create a model of it. Now, is that going to be measurable? No. Without scale constraints, it's not. But because of the GPS data that we have in drones, it makes it all measurable. Secondarily, if any of you guys are utilizing LiDAR, this works hand in hand with it. You can do hybrid processing. So there's use cases for that as well. Just some other general terms you're going to be running into today, or we're going to be talking about. Ortho mosaic, which we've already said. So mapping, and I can be referring to any kind of maps. So whether it's a contour map, really any kind of geographically drawn representation of an area. And then we have 3D models, or reality models, as we like to refer to them. That's just a physical 3D representation of an asset. And that's in 3 dimensions. It's a textured mesh. And then you have 3D point clouds, which is essentially your mesh, but it represents a point in space for every single spot. And it has an X, Y, and Z coordinate tied to that spot, allowing you to get elevation data, allowing you to pull heights, distances. That's what allows it to work within the system. So the next question is how's this going to make your life and job easier? Well, it leads back into the problems that John was talking about and that we had at the beginning. You know, old data, especially with Google Earth, especially with these new builds and new sites going up, it could be 2 years before you see something. All you're seeing is cornfields. You have locations that's 50, 60 feet in the air. Maybe it's a 3-foot ledge that someone needs to do a roof assessment on, and you're not needing to get a crane out there. And then lastly, the human error aspect. It's impossible to eliminate human error, but we can reduce it as much as we can. So now we're going to jump in, and I'm going to show you okay, so this is a reality model, and this is on the far end of what is entirely possible with reality models. This was flown for a client for inspection purposes of the facade. So every inch of this building was flown close enough so that way I could see the cracks and all the features in the block and the brick. I could see every single inch of this building from every angle, so that way it can be inspected. This was utilized to help them in areas they couldn't reach because of the trees and other issues here, needing to get up in man lifts, needing to put someone in the air and look at these, because every 10 years, the government requires you to look at them. So there's reasons and needs for them that could be outside your normal wheelhouse. And when we zoom all the way in here, it's going to take a second for it to fully clear up. You're able to see that crack block, the brick, you see the exposed mortar, and you're really getting all this information. And it's not just a flat image. You could look around, you can move around. It gives you perspective. It feels like you're there. So it really helps. Our estimator has loved it, and how much time it doesn't take him anymore to have to go through all the photos just to get a feel of the job. You know, how's it sloping? How's it draining? You know, it takes a minute just to get the feel. And it's just helped him a ton. And primarily for viewing and visualization, secondarily, that's where we come in with the point cloud. And I'll let John take it from here.
Okay, so this is a, excuse me, a point cloud of a project we just completed. This project was in excess of, $2 million for the re-roof. It was about 3 hours away from us. And with our flight that took about 3 hours to fly this and some additional time for processing, we never had to go back out to this site to verify or collaborate with our subs to get pricing for different things like stair towers and wall lifts and heights and reaches and ranges. But the interesting piece of this is you're able to go in here and measure the curb height flashings at your computer desk. So when our estimator is looking at this project, he's able to interact with this, not from a report, not through AI, but through real interaction and visually being able to determine factors right out of the gate. So we're not confirming or denying accuracy. We're delivering accuracy with our own eyes. So just having this functionality to be able to virtually do a takeoff took a lot of pressure off of our takeoff team to go out there and count all these issues and all the penetrations and lightning protection we had to rework. And We collaborated with our lightning protection sub over where the air terminals were, stair tower, unit, and then we got into pre-bid scope reviews or scope reviewing with the client. We pulled this imagery up and we started talking about what our logistic plans were. And this job became not about money. It just became about confidence in the roofing contractor. So a lot of bonuses to this initial step. One of the interesting tools that works inside of this is the cut through. I just find that super fascinating how we're able to see drain bowls through a cut through the building. And Kara can explain to you how we go through this.
So essentially all you're seeing here is it's cropping out a clip of this red band of the point cloud. And if you follow the little bubble here on the bottom, you'll see that it's on the top up here as well. And you'll see if we follow that down, that ends up what we believe to be what we would assume to be the drain ring. And if you zoom in here, you can actually see we're actually able to capture points of the drain bowl. So you're able to see the line goes in, goes down, we picked up those drain bolts, and then it's climbing again. So you're seeing with that profile cut, you're able to see the outside of your buildings, more or less which way is the roof sloping, and gives you a quick overall idea of what's going on. It's also fully exportable because the point cloud itself is 20 gigabytes. So, I mean, even a lot of workstations are going to really struggle with that. And this is a, $500-600 computer that we're working on in the office in our conference room. Don't need a workstation. That's part of what is so powerful about the Optello system is the ability to actually utilize these assets and not be stuck behind my computer the whole time, which is my limitations before. Another thing you could do in here as well is you can create labels. So with this, you can tie it to literally anything in the system, whether that's another photo, whether that's a report, whether that's a CAD file, whether that's a drawing. It's really easy to just throw something in here, throw in a label, and then you can save it. And it tags it to that point, so that way it's displayed on there. And then you're able to pull it up. So you're able to directly put it on the roof, show the issue, and then go into it. So you're able to communicate in one area, what is it, the issue that's going on, or what do you want to see? And jobs can be set up for an estimator fully for them to essentially stay in the point cloud. So that way they have all their measurements, all their pictures attached, and they're not going to a bunch of different places to figure things out. Lastly, with the point cloud that's nice is you have your elevation data. So like I said earlier, all your points in space are colorized or given a set of X, Y, and Z coordinates. And what that does is it allows us to colorize the point cloud. So as you can see here, and we'll tighten it up with the distances. So pull this guy, bring it up, and then we'll bring the other one down, and you'll be able to see essentially, and you could see where the drains are at or where the low spots are at in the roof. Bring this up a little more, and you could see where that drain line is, and then it's going back up, and the same thing over here. So you're able to see, there's your drains, there's your other drains, just a quick view. And also another tool is, you're able to pull slope. So there's just a ton of tools in this system. So you got about a 1 degree slope going back towards the drain. So there's a ton of tools in the system to really do anything that you could really need. And that, kind of closes it out for the 3D portion. Trying to be a little quick here. And then going into comparison of, here's, maybe you don't like 2D or 3D, maybe you're not used to 3D. Some people it's overwhelming. Some people just want to go back to that standard, what's, Google Earth kind of 2D looking down. So you have your high res ortho. So you're looking down and you're able to take measurements within the system, draw lines, So I can do a line measurement. I can do area measurements. You can place objects. It's all able to be put in the system. You can do different layers depending on what you want that to be in or display. Secondarily, what you're seeing, and this is one of the biggest uses of the system that nobody else has because of their Optelos's patent, is what I like to call location intelligence. And all these pictures you're seeing were taken by a cell phone months and months before we'd even heard of Optelos. So you could see here, these photos are being pulled. You're seeing the direction that they're facing. You're seeing the angle, you're seeing the field of view, and you can pull that up in the photo as well. So you've got a lat long that's here, you've got a height, and you're actually able to see when you're looking at these, okay, where am I at on the map? And same thing, and it's changing directions, as you can see. So you're pointing straight ahead that way, and now you're turning right. So this enables you to have to take a lot less pictures and gives you better perspective when necessary. Another really cool feature with this ortho is you can do an ortho compare. So you can compare two separate dates, still have the same resolution. You zoom in, that comparison, or you can do a multi-ortho overlay. So you can do a comparison over time, and you can watch as you progress how that job went, how it was looking, where you get to along each week. What this enables you to do, especially if you do it week after week, is you can then do time studies. Okay, how far did we get this week? Why? How far did we get this week? Why? Well, okay, GC said that we caused an issue over here. Well, no, we didn't. We have proof right here. So you then begin to protect yourself long-term as well by having data to back up what you're saying. And then to show you a comparison of your drone photos, let's throw a few in here. But what I'm doing here is I'm turning on the photos and turning them off. So what you're able to do within the system is, okay, let's see progress. If I wanted to, I can turn them all on, I can turn them all off. I could see specific ones. So you can have different dates of different photos in here, and you have a ton of features. Secondarily, what Optelos allows you to do from fly view is you have the ability to, these annotations, tasks, issues, tags, well, these become highly useful as you start to work in the system. So as we work in the system, and let's just say if we wanted to select all, pull every photo from this job, it's going to take a second. We can pull just this annotations, and it's only going to show the annotation photos. So these are the only photos out of a few thousand that have annotations on them. And if you go directly into those photos, you'll see what those annotations are. So like this, took a 360 photo, tied in an annotation to it, tied into the plan view. So you're able to tie multiple documents together, you're able to tie multiple details together, and the more things you put in the system, the faster it becomes filterable. And like I was saying for the annotation piece up here, it works the same on the right, because you can do, okay, I just want this picture, or just this issue, just this annotation, just this tag. So you're filtering a ton of data just by flipping on a few keyword searches, essentially. And the ease of how you get to that point is really simple, because essentially what we have our takeoff guy do, he comes in and he just uploads all the photos. Once he comes in and uploads all the photos, all he has to do is select and grab them, just like you do in a Windows computer. And then you can edit them, is what it's called. And we can tag all these to one core. So we could say that these are core 1. What this allows us then to do is it becomes filterable in the system. So every action leads you to a better organized system that you're able to find everything in. and it also has the location tied into these guys. So you're then able, okay, where was that core? When was it? And you're not having to go through as much steps to be like, all right, picture from far back, closer, closer, ensure we have perspective. And I mean, that covers down on, I would say, the primary use cases of a lot of the takeoff side of it. There are some reports, there's some jobs features in here, notes. So there's some other management features within the system. And I think going into the assessment side of it is where you're going to see another piece. But what we believe in is realistically, you really still need somebody up there on that roof. But there are times and places that are just really hard to reach or hard to see. Yeah, you can get up there. Yeah, you can look around, but how are you going to get on the other side of that screen wall? It's a little 6-inch gap. So now you have imagery right here that you're able to jump directly into. You're not just searching through a bunch of files, scrolling through them. You go directly to the image that you want to see of that roof of that area. And it's very easy to either click on them like I was showing, or you just grab a box and you can just grab a group of them. And then once you get into the system, you just mark up that area, tag the issue, and move on. Secondarily, I mean, we've found a lot of benefits with client usage and how we've been able to retain clients. And maybe John would like to explain some of that.
Yeah, so for preventive maintenance and roof assessments where we go out and we're really very active in the service and repair side of things, and we bundle imagery up with our preventive maintenance program for our property managers, and through the Optelos platform, we're able to set them up as a client and transition this imagery into their folder so that they can have access, you know, for as long as they want to maybe assess their parking lot for cracks or broken drain swales or drain sumps and landscaping or whatever they might need it for. And they really find, you know, additional enhancements from what we're providing them for roofing. So we can charge them for this imagery, or we can just use this as an advantage, you know, strategically to retain our clients. So just a value add, and it doesn't really cost us a lot of money to go out there and fly this building. Maybe it took us 45 minutes to fly this building, and it keeps a, you know, $500,000 client happy. So, you know, it's all relative. For us, we're not a huge company. We're a medium-sized company, and we invested, you know, probably the price of a pickup truck into this, and our return on that investment has been, I mean, I really can't begin to count the amount of money or the time we've saved. Safety is another huge aspect of things, that we'll fly our drones out on job site inspections and stream back live information to our project managers so that they can, you know, see what's going on and, you know, adjust safety if we need to. So the use cases can go on, and we have limited time here today, but the idea is just to show you a little bit about what it looks like. And I know John Kenny's been very excited about his utilization with it, and maybe John wants to speak to some of that.
Sure. So for us, when I look at technology like this, it's what can I do with it? Because, you know, I'm not going to be the estimator. I'm not going to be the tool of this. So I look at it, where can I take it next to make improvements in the industry, and what we love to do, training, right? We all need more and more training in the industry to make everybody better and better in all positions. So because of the 2D and especially the 3D modeling that you've seen the examples of, and what really hit me the most is the detailed, you can get down and you can see every seam in a roof. You can see the flashing cracks. You can see it all very well detailed, which you really can't in other technologies. So what we're going to do with that in the simplest format is take it and turn it into training. For example, like estimating training, we'd be able to make that an enhancement onto, you teach the basics, you got to get the hard skills down, you get the soft skills. This is more an advancement. How do you go out and do a proper takeoff? What do you look for teach them how, why, when you got a unit that's only 6 inches off the roof, it's going to take extra time, or where the setup areas are. So by taking that, then going to the next level, which I really thought was very important, is I know when I was on the industry side, the hardest part is getting these handoffs right, and to get your people to know how to set up jobs properly and how to go out and manage your jobs properly. So we're going to take all this and move that same way into training for different operational formats in there too, because where this comes in, you won't see it where we're not going to take it and have you where you're operating the system like you will do on this end. We're going to take these, it's almost kind of like a movie shot. We're going to walk you through scenarios. You're going to feel like you're right up on the roof, wherever you got to go, have start-stop points where we're going to be run you through scenarios, what you would do in these scenarios and how you learn from it, but not just for the estimating side, but right on up through to the operational. And also, as John touched on real quick too, about this safety scenario. I mean, this is excellent for risk management training and roofing. You have all the ultimate scenarios out there with all these different buildings. So we'll run multiple risk analysis scenarios to teach people how to make better decisions when they're on a job, what to look for, what not to do, and how to do that. So really, in a nutshell, because I know we're getting short on time, that's how we're taking it. We're taking these visuals and turning it into to advanced training. That's what we're going to do with it.
Thanks, John. Yeah, we definitely enjoy the partnership and collaborating. And, our goal here is to, elevate the industry any way we can. And we're here to help you with maybe where you're at in your drone flight prowess. If you're doing drone work, if you're flying a drone, taking pictures, and you want to take that to the next level, we'd love to be that partner that helps you take that next step. Carrick took somebody from our office that never touched a drone, and in 3 months, he's flying projects and bringing us back this type of imagery when he goes and does a takeoff for us. So it's not as cumbersome as you may think.
Hey, so thank you guys. That was really impressive. Very cool. I love the 3D model that you've started with for examining that facade. Every crack and everything could be visible. Do you guys have any questions? We only have a couple of minutes, but I'll open it up if there's any questions.
Contact info.
Contact info. Jason, good question. John?
Sure, that's Jay Kiesel, Kiesel, at imaginetechnologiesgroup.com, and K Willis, KWILLIS, at imaginetechnologiesgroup.com.
Did you say Imagine Technologies Group?
Correct.
Karen, can you send it out to the group when we're done?
Yep.
Yes.
Well, I think I have your Division 7 emails, but
Well done, guys. Very impressive.
Thank you.
yeah, thanks. All right, everyone, there's John's. Okay, let me get my